No.
Open playground means it's running locally. Okay.
So yeah, come here and go save a copy in Drive. So we're going to be making extensive use of collabs throughout the duration of this course. I'll show you why in a couple of seconds. So by the way, you can update the setting as well if you want to save this, if you want to save your outputs over there. But yeah, the reason that collabs is so great is it also gives you access to a free GPU, which is a Tesla K80. And you get 12 hours access to that before the notebooks reset. But you can download the weights from your neural network if you have a training one and carry on going. So that's just a hint. So yeah, all right. So let's start getting through this first exercise. Have you all got it open on your laptops? Right. So for those of you who haven't used a Jupyter Notebooks before, this is Colabs. It is just a fork of the Jupyter Notebooks project. And the way it works is you have, text blocks and you have code cell blocks. So the first thing we want to do, code cell blocks, you can run. You can actually run the code live in your browser. And in this case, we have a free VM on the other side of the earth somewhere doing the compute for us. And you can also, if you want, using wiki markdown syntax, you can write notes. So that's essentially what a Jupyter Notebook is. So what you want to do here is, first you want to connect to an instance somewhere. So the first thing you do is click connect. Okay. So you should all have a little green arrow next to your connected box here. So unfortunately, Colabs does not come with Gym pre-installed, so we have to run this command by clicking this little play button that runs the command live in your browser. And I've put some fancy syntax here to mute the outputs, so there's some stuff being generated. Once we know that a command's executed successfully in a Jupyter Notebook by when the little numbers appear next to it, so you can see that these commands haven't been executed yet, and they don't have numbers next to them. This one has. So, yep, this ran correctly. The next, we've installed the library. Now we want to import it into the memory. So we run the next command. Okay. So like I talked about in the lecture, Gym gives us this. It's a wrapper that gives us an interface to common inputs and outputs of a whole bunch of different environments. So to get a list of those environments that it gives us access to, click this play button, and it prints out a list of all the environments that you, in your own time, both after this tonight and going forward into the future, you can play around with all these different environments. There's a lot here. There's a lot. So just as an example, if I can move this across, doesn't seem to want to go. There we go. So we got card pole. You guys are going to get quite familiar with that guy. Lunar lander, it's quite a famous one as well, trying to land a little thing on the moon. Bipedal walker, that's a really good one too, once you get to the advanced stage of reinforcement learning, to have a play with that guy. And then there's several other ones from Atari, but you get the point. There's a whole bunch of different environments that OpenAI Gym gives us a common interface with. Right. So, unfortunately, it doesn't give us a multi-armed Bandit environment, so we're going to have to download that off somebody's Git repository and install it. So just run the next two commands. Oop. All right, so we now should have a multi-armed Bandit environment installed in our memory to play around with by clicking this one. Okay, so again, in our example we gave in the lecture just before, we had 2 bandits that we're looking at. In this little problem set, we're going to be looking at 10 bandits. So I know this picture only shows 7, but it sort of gets the point across. We're going to have 10 different slot machines, 10 different options, which have hidden distributions, which we don't know yet. Via sampling, we're going to sample them, gather data, and try to figure out which one of our bandits pays out the highest return. Okay? So that's the multi-armed bandit in a nutshell. And if any of you guys are more like you learn through reading, there's plenty of notes here to walk you through this as well, if you're not catching anything I've said. So it's our goal to try and determine which bandit out of the 10 pays out the most. So the first thing we want to do is we want to make an environment variable to hold our environment. In this case, we are creating a 10-armed bandit environment. So by running this command, we are creating a 10-armed bandit environment. Pretty straightforward. All right, so this next part of code is doesn't have any machine learning in it yet. That's the thing you need to know. But we're going to run this, and then we're going to walk through its outputs to sort of understand what's going on at a very high level for OpenAI Gym. This is the sort of common interface and the common inputs and outputs that we talked about earlier. So let's run this. So it should print out about 5 times, I believe. So we're going to take apart each sort of line of code here and see what's going on under the hood. So we alluded to this earlier, but unlike the other sort of genres of machine learning, reinforcement learning is kind of in its own little category, and we'll deep dive into, in a future lecture, we'll actually deep dive into why that is. But for now, it's good to understand that reinforcement learning is kind of this framework, and it's this framework that's on the screen right now, right? So I'll explain it, and then we can see how it's implemented in the code. So you have an agent. In this case, it's a human brain. Of course, it's a human brain doing machine learning. And your agent, this is where you usually substitute your algorithm. Your agent takes an action. In the case of Space Invaders, there are, I believe, 5 actions available to you. You can go down, there's 3. You can either go left, go right, or shoot. So there's 3 actions that are available to you. You take an action, you feed your action into your environment, which is the Atari game console here, that produces 2 things. At this step, it produces 2 things. So it produces a reward, which is fed back to your agent, and then it produces the next state, the next bit of information that your reinforcement learning algorithm is going to take in and then interpret and then do something. So it takes the information in, based on what your algorithm is, takes another action, which is fed into the environment, which produces a reward and a new state, and this goes on and on. And this is reinforcement learning in a nutshell. Okay? So let's see how Jim implemented this little diagram below. So this is pretty much explaining what we just talked about before. So we created our environment, and that's held in the env variable. The very first thing we need to do, so say you wake up in the morning, you get some light that comes into your eyes, and that's the very first piece of information you get to start making decisions for the rest of the day. We need to do the same thing with Jim, so we need to reset it, and that provides our very first observation. So again, observation is a technical word. We also call this state in reinforcement learning. It has 2 names, observation or state. And what that is like in the diagram just before, a state. One example of a state is just this very image here. You know, state number 2 might be the image after it. State number 3 might be the image after that. Or we can also call it observation. It means the same thing. So the very first thing we do is we reset our environment. So in reinforcement learning, every playthrough of a game or simulation through an environment is called an episode. That's the technical name we give it, right? In our little loop that we did prior, we did 5 loops, so 5 episodes. And what we did was first as a caveat, we are dealing with the 10 armed multi-armed bandit problem, so there's not 2, there's 10. And what that means, okay, it's a very crucial thing that we understand this. We've got 10 bandits that we can pull, so that we can get information on, that we can sample. But we can prove that this is the case by running this line of code. And what this does, again, don't freak out or anything. The action space is just essentially an array, a table of all the actions that are available to us for that specific environment, right? So for the 10 armed bandit problem, how many actions do you think are available to us? Anyone? For the 2 armed bandit problem? And if for Space Invaders? Yeah, that's pretty much it. So if we're playing Space Invaders, our action space will be an array of 3, starting at 0, obviously. So we can prove that by running this line of code, and it comes back as, funny enough, 10. All right, so the next, just to again stress, we haven't done any machine learning yet. We aren't doing anything. We're just walking through how Gym works. So the next thing is we take an action. This is usually where you would plug in your reinforcement learning algorithm or whatever. So that's this line of code here. But in this example, all we are doing is we are sampling the action space. So to go back to this thing here, so all we're doing is we're saying, at random, give me an action to take. We're sampling it, just at random, okay? We take an action, that's very good. So it's going to be some number between 0 and 9, okay? Now what we do next is the interesting part. We take our action and we feed it into our environment variable, which we created earlier, via the step function. And that produces these things here, the new state and the new reward from our action. So again, we get our brand new state from waking up in the morning. We decide to take an action. The action is fed into our environment, which produces 2 new things, a reward and the new state, which is then fed back in, and we carry on going. Just this, over and over and over. So there's 2 other things that Gym produces. It produces done and info. We don't need to know about these yet, so just ignore them. If you are, I think a lot of you guys are. As a caveat as well, we looked at a lot of your code to get into this course. We actually looked at all your coded up examples. So there's quite a few interesting answers to there. But yeah. But yeah, so you could literally just do this. You can ignore this as an output, sorry. All right, okay, so this is essentially the final piece of the puzzle, and then I can hand this over to you guys to sort of code up in the next 10 minutes, or on your own time at home. But okay, so the last piece of the puzzle is this thing called the reward average sampling learning rule, okay? So the Epsilon-Greedy algorithm is kind of a synthesis between 2 ideas. You're combining a purely exploratory agent. Now, if you had the case of an exploratory agent, just purely exploratory, it would just randomly sample all your actions that are available to you forever. Just that's all it would do. If you had a purely greedy agent, it would, it would find. It would be like a dragon. It would find like a pot of gold. It would find and just sit on it and just sit there forever. Like it would would find one option and just sit on it. So the Epsilon-Greedy algorithm is kind of like a synthesis between these two ideas. But like we use epsilon like we talked about previously as a volume knob to control the ratio between these two things. So one way of saying that is like we take an epsilon chance at doing an exploratory action. Okay? And the greedy mechanism helps us sort of focus in on the best option that we've found so far. But say we've got these 10 bandits. How do we then assign the idea, how do we teach the machine the concept of value? How do we say, okay, this bandit over here has a higher value than this bandit over here, okay? And we do it via this algorithm, or this little piece of math. So I'm going to walk through what that is. It's pretty straightforward, okay? Let's say we have, again, our 10-armed bandit problem. We want to create an array that holds 10 variables, because we want to like keep track of how well this one is doing, how well bandit number 2 is doing, how well bandit number 3 is doing, etc. Okay? And we call, okay, so the name deepQN, the Q comes from this. Its formal name is quality. Okay? It's kind of a lame name, but anyways, that's what they decided to name it. And N is the amount of times we have visited that particular option, or in this case, slot machine bandit. So say I go to slot machine 1 and pull it 3 times, N is 3. If I go to slot machine 2 and pull it 2 times, N is 2. But we need to keep track of this separately for each option that's available to us, okay? Now, if you're dealing with a problem where you have many different options, many different actions you can take, and the problem's going to run for a while, you can quickly see that this algorithm, or if you're having to like remember every single reward for like, I visit this, I get a reward, remember that, revisit the slot machine, remember the reward that came out, you'd quickly run out of memory, even with today's computers, okay? So we use a little bit of mathematical trickery and get to this version of the equation. It's exactly the same thing, but all we are doing here is essentially compressing down, instead of having to remember every